moment of inertia. The first question which needs a solution is what moment of inertia is. But before discussing about moment of inertia, let's discuss about inertia. So what is inertia? As we have already studied, inertia is the inability of any body to translate by itself. And in that case, we have studied three parts of inertia, in which one of the part was inertia of direction. According to me, inertia of direction may be grouped or may be explained in two ways. In the first way, when the axis is at rest, or you can say the axis is fixed. And second, if axis is changing. So, what will happen if the axis is fixed? If the axis will fixed, the body will rotate about a fixed axis, and the inertia of direction can be called rotational inertia, which is the same as moment of inertia. So, moment of inertia may be explained as the inability of any body to undergo rotational motion by itself or undergo rotation by itself. As mass is the measure of inertia, thus using the concept of analogity, we can say moment of inertia is analogous to the mass of translational motion. Defining it in form, we can say moment of inertia is the inability of any rigid body, as you have studied earlier, the rigid body to undergo rotation by itself. As I have already stated that moment of inertia is analogous to the mass of translational motion. But basically, unlike mass, the moment of inertia depends upon the distribution of mass inside any system. So firstly, we have to understand how the mass is distributed inside any system. Basically, the distribution of mass inside any system can be done in two ways. The first way is variable distribution of mass, and the second is uniform or continuous distribution of mass. Now firstly, let us explain what variable distribution of mass is, and the second is what is the value of moment of inertia for variable mass distribution. We can say if the mass at different point of any system is different, or the mass of different point of any system is different, then the distribution is called variable mass distribution. In order to explain my point, let us take an illustration. Let us consider a rigid body as seen in figure, such that different masses m1, m2, m3, m4, mn, etc. are placed at distance r1, r2, r3, r4 and rn respectively. The system is called variable mass system. Now we are going to calculate the moment of inertia of variable mass system. For variable mass system, the moment of inertia I is given by m1 r1 square, where m1 is the mass of that particle and r1 is the distance of that particle from the axis of rotation. m2 r2 square, m3 r3 square going on to mn rn square. We are taking the sum of individual moments, or you can say it is equal to, let us consider an ith particle. The summation can be taken, I can be given as summation of I is equal to 1 to n mi square. Now let's know what is continuous mass system. If the mass at every point of the system remains the same, the distribution is called continuous mass distribution. Let's consider this rod having length L and total mass m. Each and every part of the rod is uniform, and thus it can be considered as a uniform mass system. Now the moment of inertia for uniform mass system may be given as, the summation will be replaced by integration of r square multiplied by dm, where dm is the elementary mass and r is the distance of that elementary mass from the axis.